Hi folks, and welcome back to Math with Captain Rod. Making this video here to describe what's called the dot product in vector mathematics here. So we're taking a look at a couple of vectors here that I've already drawn. Vector A that I've got drawn kind of up and to the right, and here's a vector that I called B, which points to the right. This angle theta is the angle between A and B. And before I talk about the dot product specifically, let's talk about vector A in terms of components. If I took vector A and broke it into components that were parallel to B and perpendicular to B, and I'm going to draw these in red. I'm going to offset that just a tad. So the component of A that is parallel to B would look something like this. I'm going to put A, let's call that parallel there. And then the component perpendicular might look something like this. Now usually when I draw vector components, I usually would draw them like over and up. I'm going to go ahead and leave it like this, but the important thing to realize is that the vector sum of this one and this one would give you vector A. So here's the component parallel to B, here's the component perpendicular to B. And there's two different ways, if you're thinking about like multiplication, vectors can be multiplied with two different methods, if you will. Sometimes you're looking for B times the component of a vector that's parallel to it, and sometimes you're looking for B times the component of a vector that's perpendicular to it. In this specific video, we're working on, or I'm just trying to describe what's called the dot product. And the dot product is all about this one. When you take the component of one vector parallel to another vector and then multiply them. And it's pretty easy to show by right angle trig. I'll go ahead now and move this one over. If you look at this triangle right here, this guy, the one I called A parallel here, that's the component of A parallel to B, is adjacent to the angle theta. So this is equal to the magnitude of vector A times the cosine of the angle theta. So now if we multiply these, this times this, we get what's called the dot product, and I wrote it out right here. A dot B is equal to the magnitude of A times the cosine of the angle theta. That gives you the component of A in the direction of B, and then times B. It's usually written like this, AB cosine theta. And again, it's important to note these are magnitudes. Magnitude of A, magnitude of B, times cosine of the angle between them. Now the dot product has certain, I guess I'll say, symmetries to it. You could also take B, and if I broke it into components that are perpendicular and parallel to A, they might look something like this. The parallel part looks like maybe this, the perpendicular part like so. So magnitude of B cosine theta, that gives the component of B in the direction of A times A. So it doesn't really matter which way you want to think about it. It gives you the component of one vector in the direction of the other, and then multiplies them. It also, order doesn't matter. A dot B gives you exactly the same thing as B dot A. Magnitude of A, magnitude of B, cosine of the angle between them. In component form, it looks like this. You take AX times BX plus AY times BY and add them together. Now, a very important fact of the dot product. You'll notice here when you take a magnitude, that's not a vector anymore. Take the magnitude of B, that's not a vector anymore. And cosine theta is, of course, not a vector. So an important thing to realize is when you dot two vectors, you get a number, not a vector. It could be plus or minus, depending on the angle between them. When this angle is less than 90 degrees, the cosine is positive, and you get a positive value. However, say theta were between 90 and 180, like maybe 120 degrees. The cosine is a negative number at that point. So you can get a negative number out of the dot product. So that's what a dot product is and how it's calculated. One more time, I'll kind of overview it. A dot B gives the component of one vector in the direction of the other and then multiplies them. Order doesn't matter. You can do a dot b and b dot a. You get exactly the same thing. Here's how it's calculated. Magnitude of the first times magnitude of the second times the cosine of the angle between them. Or in component form, it's ax bx plus ay by. And you get a number out of this, not a vector. A real common example of a dot product in physics, probably the first example I can think of that you would normally see, is work. You know, if you have some sort of force acting on an object in some sort of direction, but that object is moving in a different direction, maybe this way. Here's a displacement vector, maybe a change in r. The work done would be the component of this force in the direction of the delta r here, which would be magnitude of f cosine theta times this distance, which is the magnitude of what I just called delta r. So that's the first example I can think of in physics, but there's many, many more. So anyway, this is just meant to be an introductory video on what the dot product is. Have a great day.